Hello. So I am going to record a tutorial today. This is about this sort of art piece. I don't know what you call it, concentric circles, growth, inflation. I'm not really sure, but it's a pretty versatile little tool. You can pretty much plug any shape in the middle here. I mean, this is done as a 2D effect. Probably you could do something similar with 3D, but I'm kind of trying to use this for like graphic design stuff. So I'm just doing it in 2D. You can also do it with text. I've been working on some like logos for my bands. Here's an example, and then this is another example. But you can do a lot of different styles with this. It doesn't necessarily even have to be this concentric circle thing either. You could just like expand the text. And unlike some of my other tutorials, I'm not showing like a tool I've built or a utility in Houdini. I'm just going to be showing building the node network from scratch. I did this a while ago, basically, and I lost the original file in my hard drive somewhere, and then I found it. And I've done a bunch of work on simplifying the process and kind of getting it down to the fundamental steps you need. But basically, the way this works is using SDF functions. So if you don't know what an SDF is, it's a signed distance function. So we look at Wikipedia right here, and basically when you go in Houdini and you create like a volume, for example. So like I just create like a cube right here, and then I'm gonna do VDV from polygons. That's actually gonna create an SDF. If I lower the resolution, I don't know. Maybe a sphere would be a better because it kind of voxelizes it, stuff like that. Ooh, let's see. Do I need to? I think I need to. Yeah, so you can see it's producing voxels here. And how this so you can see there's a distance VDB. This is the options. You either have a distance or fog in the VDB from polygons, and how the SDF works, which is the distance sign distance field you're creating, is you can get a number out of it. It says right here, this function has positive values at points inside, decreases as you approach the surface, and negative values outside. So that would be like if I'm sampling a point, say inside this thing, it's saying this. It would give you a positive value. And if you sample a point way outside of it, it would give you a negative value. And if you sample one right on the surface, it would give you 0. And then it's also saying here the alternative convention is also sometimes taken negative values inside and positive outside. And I think that's what Houdini is doing. And I learned about this from Junichiro Horikawa's algorithmic design series. This episode on SDF Basics. I really recommend this series. It's like, I mean, I can't even thank him enough for putting that out there. I've learned so much. I do recommend that, but I'm just going to be focusing on this one particular effect, and it's just using basically two functions here: this volume sample and volume gradient. Volume sample just gives you that number that I talked about. Oh, you can sample a point and get a negative, positive number. Volume gradient gets the direction that you are moving. So, for example, if you're inside the SDF, it'll give you the direction to the surface. So that's basically how we're going to grow our shape. We start from here. We're going to convert it into a sign distance field. And then for every point on the outsides of our input, we're going to, find that direction towards the outside of the SDF, and we're going to move in that direction. And that's how it expands outward. And how you kind of get these not to self-intersect here is you use the volume sample, because as I'm growing outward, I'm also checking, well, is the point I'm moving inside of the SDF? And if it is, then I'm not going to move it. For example, the SDF, when I try and move this one over here, it sees, oh, that's inside the SDF, so I'm actually not going to move that point anymore. Anyway, I think it's better just to get right into it. So I have this empty Houdini scene right here, and I'm going to do this with font. So I'm going to go front view with space 3, space F to frame it. I'm going to type some text in here. Let's say text FX, like that. And then you can see the points here. And so I am going to resample this because we are going to be moving the points. So we want it to, everything to move evenly. So I'm going to give it a pretty small resample length here, and then basically I'm going to dive right into a solver. It is possible to do this using a for each loop, but I think it's better to use a solver. You can kind of see it growing, which is pretty cool. Yeah, give me 1 second here. Okay, so in this solver, we're just going to kind of get right into it. It's not actually that complicated of a network, but so we take our input and we are going to, like I said, do a VDB from polygons here. And we should be able to see this right away. Now this is obviously doesn't look like much, so let's just get it so it looks more accurate by lowering the voxel size here. And then I'm going to write a point wrangle, and this is going to do most of it for us. I'm plugging this VDB from polygons into the second input here. Because I'm going to manipulate the first input using the VDB. And so, yeah, what I'm going to do here is basically I'm going to sample the VDB value at that position. So I do float like SDF val equals volume sample. It's going to be input 1, which is the second plugin here. And then 0 just means like it's the first volume contained in this VDB from polygons. So you don't really have to worry about that unless you're doing like multiple volume values, which you can see Junichiro's series on volumes to understand more about that. But, you know, I just use 0 here. And then for the last one, I'm just going to plug in at P for my position. And then I'm going to say if SDF val is greater than 0, and if not, then I'm not going to do anything. So I'm only going to move the ones that aren't already inside of the SDF. And then what I'm going to do is I'm going to get the direction of movement. So I say vector dir equals volume gradient. And it's basically the same arguments here at P. And then I'm going to get, let's say, like a speed value here, which is going to be how much it's going to move per frame. So let's just set it something small for now. And I'm going to now calculate the new position. So vector new position equals at P plus dir times speed. And I can then assign that back to my position. And at this point, we should be able to see some sort of movement. Now, why isn't that not working? Give me 1 second. I'm going to have to figure it out. Okay, so I didn't really have to change anything there. I don't know what happened. I think that was just like a viewport bug. Sometimes you get issues with the cache and you have to go back, but I didn't really change anything. Voxel size is still low. Movement speed is still low, so yeah, I don't know. But yeah, here you can see the text growing out, and obviously there's some issues here. First of all, I don't really like, obviously moving our points like this is going to create broken polygons. So basically what I want to do is just get a wireframe. So I tend to use, I like just using this ends node. Pretty straightforward. You do close U, unroll with new points. Now that's not working. Why? Because after the first frame, our input is a wireframe, and we can't like VDB, you know, a wireframe. So I'm gonna just basically go right here and then add another ends node, but this one's actually going to be closing the polygon. So I use close U, close straight, and at that point now, okay, if I put my focus on the output, we should be getting our wireframe expanding out here. Now it obviously does look a little bit messed up, and so one thing that I think we do need is to resample our input. because we are growing, and then we're not resampling it as it grows. So I think I'm just going to copy paste that same resample in here. That should help to some degree. We're still getting this sort of weird type of situation in here with all these like squigglies. Now, why is that happening? Let me just check my reference. Okay, I just remembered. Actually, this is the same thing that's hung me up before as well when I was, doing my reference version of this. Basically, so if I look in the 3D view here, you can see that it's actually expanding out in 3D, and so that's what's going on with that. So all I need to do right here is I just need to zero out the z-axis on the new position, and that pretty much fixes that problem. Now we do have some sort of little, I don't know what you want to call those things, like creases. But I think that could be a desirable effect. It can look kind of cool, and there's a couple parameters we can play with here as well. I mean, speed obviously will have an impact. I mean, you're going to get sort of less accuracy, and obviously when I decrease the speed here, getting a lot more of those sort of veiny things. When this is a pretty cool effect, so it's all stylistic. There's no, wrong answers in art, I suppose, as I say. But another thing you can mess with is the voxel size. So you don't necessarily have to make your thing super accurate. Like, for example, if I just load this by like 10x, like it hardly even looks like the thing anymore, but it actually will still grow the text kind of reasonably here. And as you see, the effect is it doesn't move them as close to each other, and these sort of ridges are larger. So this could be a stylistic thing as well. Yeah, so those are kind of, I think that's kind of the main thing. Oh yeah, there was one other like main point I wanted to, or one point of configuration, I suppose, which is actually about this direction of movement. So this is a vector, but it's not a normalized vector. So these lines are not all moving at the same amount. I mean, you can probably see these ones out here are moving slower than these ones in here. And that's because I think, I don't know, it's like they are farther or closer toward the VDB, so they're moving at different rates. And you can get a different effect by normalizing that, so I'm going to make that as an argument here. If channel integer normalize equals 1, and Houdini doesn't have booleans, so we just have to use 0 or 1 values. And if that is true, then I'm going to set dir to the normalized version of dir. I create that parameter here, and I can basically edit the parameter interface here and just change this range from 0 to 1, so it's like a toggle. You could also straight up like change this to a toggle, like no problem at all. You just drag the toggle in there, call this normalize, and toggles in Houdini actually just return 0 or 1. So here I'm normalizing it. And as you can see, I mean, you can see that everything's moving a little more evenly. It's obviously quite different. It's not creating those ridges. And I'm going to get into showing the kind of concentric circle effect. And this normalize really has a strong... This is not normalized, what you see here. But normalize looks quite different when you're doing these concentric things. So I'm going to get right into that. So the normalization, the concentric circles... Part of it is basically we're just trying to, instead of like just taking our input, modifying that input, and then feeding that back into the solver, we're basically going to like maintain our previous iterations and just like overlay them on top of each other. And when working with solvers, you kind of have to do some management of like, okay, well, if I'm accumulating a bunch of stuff into the output, I have to figure out, not all of that's going to go through this chain, obviously. So you're going to have some switch statements, some merges, things like that. So for starters, I'm going to add a group create on the input here. And I'm going to use this group called active. And all my input is going to start off active, right? So, yeah. And then in my solver here, basically I'm going to just start off the bat by doing a split node. And I'm going to split on the group active. So on the left, I have the active points. On the right, I have the inactive one. So right now, nothing should happen. We'll get the same result because we're just getting, everything's active for starters. We pass it in, everything's active at the end as well. But our inactive points here, which we actually don't have any inactive points. So let's start by creating some inactive points. What are my inactive points? Well, it's actually the previous iteration here. So that's, if you think about where I'm manipulating the points, that's in this point wrangle. So this null right here is going to be our inactive points. So we can say this previous iteration. And I'm going to take that and I'm going to do a group delete on it to remove that active group. And yeah, and actually I think at this point that's actually, yeah, that's, well, so this ends node here, this is looking fine. And yeah, so we're going to see, I think this might produce a slight issue, but I'm going to merge this in with our actual output here. And we should get group delete active. Why did that not work? Is this returning? Yeah, okay. So you can see it's returning the previous frame. It's returning the current frame and the previous frame. But it's not returning any of the other stuff, so we just also need to merge in our inactive stuff. So I'm going to make another merge right out here, and just merge our stuff that was. So here we get this result here, and this was the issue I was talking about. You can see the initial input. Everything else is just a line, but our initial iteration is actually a solid shape. So all I have to do here is move this ends node to before the... so that's the one that's turning it into a solid, right? But I think I can just create another ends node right here and just force it into a wireframe. That should just do that. Yeah, so there you go. So now we have that result. And I think this is like not... it's a little too close together. So I can decrease my movement a bit. Okay, maybe not that much, but yeah, something like that. And you can see here, or maybe even a little bit less, to be honest. I think a little bit less. Or wait, more? Sorry, I meant... Wait, no. Wait, yeah. Okay, sorry. So the greater the speed, the farther apart the lines are going to be, basically. Because it's moving more every frame. So that's cool. And this is the normalized result. And you can see how even it is. And it's pretty cool how it sort of shows the contours or gradients of the lines emanating outward. I think it's a really cool effect. And if I turn the normalize off, you can see how different it is. You have all those kind of wavy lines and stuff, which is pretty cool. It's like a lot more organic looking. We can mess with the VDB resolution here, and we'll get like a different effect, sort of like more blobby, I guess. Yeah, and even more speed, huh? So that's a cool kind of thing. Yeah, so yeah, I like this thing a little bit lower, actually. I mean, I'm just kind of playing around with this. You get the idea. You mess with this stuff. Another thing you can do is play with the color. I mean, and for to be honest, this is mainly what I'm trying to show in this tutorial. That was pretty much it. I'm just going to show a little bit, a couple like fun little post-process examples, and also just an idea about color as well. So I think out here, I believe at the end of our solver we have connected pieces. We have 150 connected pieces. So if I pack each connected piece, Yeah, okay, so this isn't, so you could do something with this. You can see each of these lines is a connected piece. Sort of each letter in each line has its own connected piece. So you could do something with the coloring of that or further manipulation. And say I want like, how do I put this? Say I want different colors for each iteration. I mean, it's pretty straightforward. I'm going to make another Boolean here, like if let's make a Boolean, like randomized color. Then, if that's true, then I'm just going to say at CD is like random of the frame. So that should right off the bat, okay, that Boolean is false, so I'm just going to set that to 1. And right off the bat, you're getting that. Yeah, and so that's pretty cool, and that's pretty much how I got this sort of effects. I mean, you can see these are basically the same thing. Yeah, so you know, if you could also, if you see this one right here, these ones are done a little bit differently. I'm basically using these so with a ramp. So it's a color ramp, and you just set like, let's say I know I'm going to do this up to 35 frames only. So let's get rid of this randomized color thing here. And I'm just going to say like at CD equals channel ramp of color, and then our original frame is going to be it's going to be like $F. Well, in let's just make that. I forget in Vex how you get the frame. I think it's like at frame over, let's say at frame over 35, and you do need to convert that to a float. Because otherwise, you know, you're doing integer division. So now we basically have this ramp, and I can go in here, change this ramp to be a color type. And right now it's going to be all black. Now let's just say I'm changing the outer one to blue and the inner one to red or whatever. And so yeah, you can see that. And as it gets to, yeah, so you can see how you can kind of get specific color ranges. I can also like, you know, put a yellow or whatever, put a magenta in the middle or something. I mean, you're going to have to just rerun it, but you kind of get the point here. So that's a fun thing. Another kind of cool thing you can do with this is you can actually just do manipulation on your text beforehand. So I'm actually going to do this in a subnet here. So for example, if I want to like just like randomly rotate these letters just a little bit to make kind of the original font sort of a little bit less like blocky, you can do a for each connected piece, which is going to be each letter here. I'm going to pack that. Well, actually, so what do you do in order to randomly rotate things? I mean, you can write some fancy like matrix stuff to do it. But the easier way is just to do it in a for each block, use a match size node. And this isn't really relevant to the text effect. This is just sort of a general tip. So if you don't know it, you probably do. Match size stash transform here, and then put another match size down here. Restore transform, and in here basically all my letters are at origin. And now I can just do a transform in here. I can click on my block begin, create meta import node, go to my transform, click on the cog, add spare input. This isn't technically necessary, but it makes it a little easier. Drag my metadata onto there, and now in my transform in the rotate X, right, which is what I'm trying to rotate on, I can say rand, let me command E to open this little window, rand detail -1, which is my spare input, and then iteration, and then 0. Now that's going to give me a number between 0 and 1. So I want to multiply that by like my degrees of movement, which should say like 15 for now. And I actually want this to go from -1 to 1, so I need to use a fit a 1 on my random thing, and then remap that to -1 and 1. Okay. Now we're getting, you know, different rotations. You know, we can also just add a seed in here. Let's say like 2000 plus just a different seed, right? etc. So that's going to change things around. And you can also do a point jitter at the end here. I like point jitter. It screws it up like crazy. And actually, so in here, this is why I wanted to have that pack at the beginning, because I want to like move just the entire letter around. So if you pack it, and then now every letter is its own primitive. And now the point jitter will just sort of move the letters around. So I want to just move it like a teensy bit. I'm also going to like reduce my rotation range a little bit, maybe like even 7. Just a very small amount. Point jitter, just a little bit. You can change the seed around. Now you can get kind of just like slightly different looking effects. You know, if I ruin my thing at this point, yeah, you can see it just kind of, you know, can look a little bit more organic using this kind of approach. You can also go ahead and change your fonts. Of course, you can install system fonts. One point I will make though is some of these fonts have issues when you try and do this whole faces thing. You see it's supposed to remove the little holes in here, but some of the fonts it doesn't work. So if you see that issue, just try a different font, basically. This is a fun little font. I mean, yeah, so that one's, it shouldn't be going inward like that. So you can just tweak the parameters. And I forget what the website I use. I use this one, Font Space. It's really great. You get so many different fonts here. You just click download on it. You go here, and you just go in there, and then you just double click on this TTF, and it'll install it to your system. And then you can be using Houdini. That's how I got this like whatever weird font. So anyway, I'm going to show like a little post-process effect right here. Just 2 of them. You know, obviously there's a million things you can do with it, but the first one, and by the way, I think I'm going to change this font back to something else, because that didn't really work too well. So let's just go back to Verdun. Well, Verdun is kind of boring. Yeah, that one's, that's okay. Well, what's Utopia? Nah, okay, whatever. It doesn't matter that much. Yeah, so, anyway, so after here, like, a big trick you can do is literally just smooth it out. It's kind of the entire thing. If I just crank up the iterations on this, why is that having no effect? That is odd. Sometimes if you reduce your filter quality, your noise will, your smoothing will have more of an effect. So I'm just going to like raise the smoothing by quite a dramatic amount. Maybe that was too much. It's being a little slow, but yeah. So you can see like with and without the smoothing, you get a pretty different effect. In my opinion, it looks a little cleaner because it kind of gets rid of these sorts of like really dense pockets in here, by just helping coerce those all towards each other. I think this is pretty cool. Another thing is if you want to use like a hand-drawn effect, which is very different, but this is just kind of a quick and dirty one. You can do a resample on this output here. Get it like a bit lower, so it's, or I'm sorry, a bit higher in the length, so it's starting to look a little bit messed up, but like still readable, you know, like maybe around there, I'd say. Let's keep on going a touch more. How about that? And then we put that point jitter down here. Again, want to just do it just so it's readable, but barely, yeah. So this kind of, and then we can basically animate this using floor $F over 2. So it's going to change every 2 frames with this expression. Oh, I'm sorry. And then for these ones, this one you also want to put a time shift mode up here because we are doing frame dependent point jitter. So I'm just trying to be like, okay, well, let's just say this is our image and we're just going to freeze it at frame 28. And now you can see it's kind of like jittering and it's kind of got a sort of like hand-drawn sort of effect. I mean, I think it looked better using a different configuration of the solver. Maybe I needed to do. I think the normalize is better here. Yeah. So, oops, what's going on? This is normalized, huh? Yeah, and maybe let's raise up our VDB size a bit so we're getting a little bit. What's going on? Oh, that's not good. Okay, I guess those parameters don't work too well. Wow, that's pretty trippy. Anyway, you kind of just gotta tweak these parameters. But yeah, so that's kind of the gist of it there. Not gonna go too much more into anything with this. That looks kind of decent, I guess. Yeah, so if you set the movement too high, it can sometimes have bad effects. And I think this video is probably longer than it probably needed to be, but yeah, you can see this is more like the effect I was talking about with the hand-drawn thing. I think it's a kind of cool effect. Yeah, that's pretty. I hope you enjoyed and you can figure it out. Cheers.